Hello and welcome to the Road to Autonomy. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to have Hayk Martiros, Vice President of Autonomy Skydio. Hayk, welcome to the podcast.
Hey, Grayson. Thanks for having me on. Excited to be here.
I'm excited to have you here because I'm going to cut to the chase. Your drones are awesome, and they make flying fun, and more importantly, they were assembled and designed and programmed in the United States. Way to go, Team Skydio.
Thanks. It's great to hear a happy customer.
Yeah. So I've flown the DJI drones, and frankly, I found them very hard to fly. There was a large learning curve there. And when I opened the Skydio in the box, I hit the button and it flew. It was absolutely amazing. Your UI in the app is fantastic. What is the core, in your opinion, that makes Skydio different from your other drone competitors?
Yeah, well, first of all, that's great to hear that you had an easy time getting it going. That's a big part of our goal. So the whole premise of Skydio is to build a vision-based autonomous drone, a drone that uses cameras to see and understand the world around it, and then navigate in that world so that the user doesn't have to be an expert pilot. They don't have to worry about avoiding objects or knowing exactly how to have your fingers on the sticks ready to go, but rather you're just kind of interacting with this robot that you feel like you can trust. And so by making the robot more autonomous, we're trying to make it easier to use and be able to do more on its own. So it's both more accessible to people and also more scalable when you're talking about enterprise use.
When you talk about the issue of trust as a user and a fan of the product, I would say within the first 5 minutes, I learned to trust it. I have palm trees in my backyard. It didn't crash into the palm trees. It was amazing. So you have the obstacle avoidance. Why was the decision made to use a vision-based autonomous system and not something with a radar or perhaps a LiDAR?
Yeah, so the decision to use cameras, I think, comes down to just the trade-offs of what kind of quality data you get versus the size and weight and cost and power. So because so much effort has been invested into cameras, made in the volume of billions every year for cell phones and all kinds of devices, the technology has just seen enormous investment to make cameras cheaper and lighter and higher quality. And so at the end of the day, vision has an incredible amount of information. I would say it's harder to pull out in terms of software, to pull out objects, geometric data. But if you can do that in software, then it's much richer for the package you get. So that's basically our focus has been. Let's see in every direction with cameras, because that's really the only way to make a drone in our size class and our kind of price class and just make it work.
Do you also have an advantage from lower power, since the drone currently operates, the X2 for that matter of fact, 37-minute flight time? By using cameras the way you're using, does that allow you to extend that flight time versus using something that might be more power intensive?
Yeah, it's a good question. So the cameras certainly are less power intensive than if you're, for example, shooting a laser out with a LiDAR. So if you're, say, indoors mapping, say, a mine or in a dark area, then there can be a pretty power efficient way to do LiDAR. But if you're outdoors on a ski slope, how far you can see with that is pretty limited. And I would say on a drone, the interesting thing is because the propellers have to keep spinning to keep the drone up, it's usually the power of the propulsion system that takes away most of that kind of dominates the flight time over, say, the computer or the sensors. But what you get with a heavier sensor is also the weight. So I would say the weight of a LiDAR would be a bigger hit to flight time than the actual energy of the lasers. And so designing everything like form and function together to absolutely optimize for weight is kind of everything with a flying machine.
The weight, to me, there's two benefits. It's easy to travel with. It's really fun. It's really light. It's easy to launch. I've launched it in the palm of my hand. So you have the weight factor there. You're right from that, increasing the flight time. And I want to get back to the motion tracking here, because as I mentioned, the palm trees in my backyard, it avoided him. I was completely shocked. I said, oh, well, here we go. Down we go. And no, the drone did a completely wonderful job. How was that technology developed? Did you have to constantly crash a lot of drones, or how were you able to develop that technology?
Yeah, I can talk a bit about that. So, first of all, I've crashed many, many drones. No question there. So, I mean, at the end of the day, the things running on board our drone are a mix of kind of computer vision algorithms that do things like visual SLAM and localization to kind of estimate objects and landmarks in the scene around the drone along with its own motion. And added kind of on top of those types of algorithms are a lot of deep networks. And deep networks have kind of revolutionized the ability to pull out information from images, like rich semantic information. And so our obstacle avoidance system is based on deep networks that predict kind of the core information that compares images and finds geometric details about the scene. And then that kind of integrates into an overall system that builds a 3D map and is used for obstacle avoidance. And actually, we invested a huge amount of effort into this. So we were the first company and team to use deep learning for kind of robot obstacle avoidance in a real product. And we invested years of effort into that. So it actually, our very first drone didn't use deep learning for obstacle avoidance. And by making that leap, we got a huge gain in performance. So today we have a really in-depth suite of our algorithmic stack. In some ways, it has a lot of similarities to kind of what a self-driving car would need to do. But there's some kind of key differences. We're a lot more constrained. We fly in 3D and we fly in kind of unknown scenarios. So you could be in the middle of a jungle or a clown house or something, and it's not like a road scene. But on the other hand, we don't have to follow the laws of traffic, and we don't have to deal with more kind of behavioral stuff of like, okay, I need to merge lanes and try to predict if this truck is going to swerve in front of me in the same way. So we make really heavy use of kind of real data. We have tons of kind of internal log data where we log everything from all the cameras, all the algorithms. We run large scale kind of regressions and data analysis on those to iterate on our algorithms, rerun them. And then we also make heavy use of kind of simulation, both kind of photorealistic simulation for training deep networks and also behavioral simulation for trying to run a simulated person through a million different forests of different shapes and then see how the drone gets stuck and modify parameters and analyze that. So yeah, we overall just we have a really strong team of algorithmic kind of foundations, and we kind of build and iterate on that to enable all the autonomy on our drones.
I'll give you an example. My daughter calls them kissing trees. These two trees, they come together, and it's about a 6-foot clearance, and the drone's following on her bicycles. We go down the path, and it came to those trees, went around the trees, then met her on the other side. I was like, okay, I'm sold now. And she's like, Daddy, this is the coolest thing in the world. Is that an example of something where it's an unknown scene that you put into simulation? Say this could possibly happen. A tree is 6 foot, and your obstacle avoidance kicks in at 8, and it just flies around the tree, and then met her on her bike on the other side.
Yeah, that's a perfect scenario. So the closer the drone gets to objects, the more likely, it might crash. Let's say there's a wind gust or we didn't see some small branch sticking out of the tree. And the faster you're going, the more likely that is to happen, because maybe the less control you have. So there's some big trade-offs there. And at the same time, the drone is trying to avoid obstacles. It's trying to capture kind of cinematic video. It's trying to keep the person in shot. It's trying to make it look good. So there's a really complex kind of optimization problem that the drone is constantly trying to solve while flying. And those things will trade off against each other. So at some point, the drone might decide, I'm going to shoot through this gap, and I think it's the best way. At another point, you tweak it a little bit. You tweak the motion of the person or the configuration of the trees, and it might decide, I want to go around this way. I'm going to briefly occlude this person, like they might get blocked by the tree for a second, but I'm going to end up on a better side. And you might not know always exactly what's behind it, but it's guessing it's doing its best. Maybe it saw it from a previous angle. So long story short, totally, yeah, we would like simulate something like that and try to model that. And we would also analyze a log and decide, okay, it went this way, but we think it should have gone this way. What would it take in terms of the overall objectives to make our planning system want to choose the other path?
It's well done. And I'll give you another example. So there's a tree. It's tall, but there's a clearance, I would say 15 to 20 feet, and we have a rope swing on it. And so I decided, okay, let's motion track my daughter on the ropes. And this thing was amazing with the cinematography. My wife's like, how did you do that? I was like, oh, the drone did all that. I just motion tracked her and it did it. So it raises the question, how are you able to balance high quality video? I want to stress high quality video. It looks really well with autonomy without sacrificing performance, because you have a great autonomy system in there. You have high quality video. You're just looking, it's like, okay, we got to make a trade-off somewhere, but it doesn't seem like you made any trade-offs.
Yeah, well, I think you'll see trade-offs as you get more extreme scenarios, I guess I would say. I think that the key there is a lot of work put into making the autonomy system understand what's a high-quality video. And of course, a ton of that is the entire stack up of the company, from the hardware and the camera design and the optics and image tuning. As far as the kind of cinematography and video framing, so I think you just need to look at what would force a trade-off is kind of what I would think of it as. Like, if the drone can maneuver and track somebody while keeping the video cinematic, then it would prefer to do that. But if, for example, it needs to kind of aggressively catch up or have a really jerky motion to keep up with the person and keep it in view, then it will do that when it has to. And really, if you think about, you see a lot of incredible FPV pilot cinematographies. Like, they'll be, an expert pilot will be following behind a biker or do some crazy tricks. And it's kind of similar with them. Like, they will cut the scenes to get the best parts of the shot, but there are parts of the shot you don't see where they're just trying to catch up. And so I think it's kind of similar with us, and we're just trying to learn how to make all those trade-offs with kind of years of iteration in the autonomy system.
You have a very big customer in NASA. NASA used your Skydio X2 drone to film the Starliner mission landing. That's mission accomplished. That's what that says to me. What was that moment like for the Skydio team?
Oh, it's amazing to see that. I mean, I think we have a ton of aerospace and space nerds in the company. And so whenever you get to connect together kind of epic technologies and inspiring things with what we've worked on, it's always a delight to see. So I think everyone's super excited by that and saying, like, okay, well, let's start scanning and inspecting spacecraft, or let's go onto the assembly line and have our dock drones as part of that. So it gets the ideas going. And then I think another good example people often talk about is like, what if we put a Skydio drone on a Boston Dynamics robot and you could do X, Y, Z? And we have all these fun ideas, and we've talked about that as well. So any chance to kind of see our technology connected with kind of an incredible other technology, it's awesome. I'll even note one more that's recent is this company called, I think, Gravity Industries, that makes jetpacks, which is just a completely epic technology and company. And there's now a ton of video of like Skydio drones following a guy on a jetpack flying around, and they love it and we love it. It's just, yeah, awesome.
It's fantastic. I studied the company. You have call them two lines of customers. You have the extreme sports customers that want to take it surfing or they're motorbiking. And then you have, which is a very good, powerful customers in the energy sector. You have Dominion Energy. They're using Skydio X2 drones to fly beyond visual line of sight to inspect power generation facilities in 7 states. And I want to point out the important part of that. They got FAA approval. I repeat, they got FAA approval. They're not going rogue. They got FAA approval. When Dominion Energy got the FAA approval, in your opinion, was that a clear validation of Skydio's autonomy technology?
Yeah, so I think the regulatory picture is quite interesting, and it's different all around the world. And in the US, I think in some ways it slows down parts of the industry, the regulation, but also it's good to be cautious, of course. And so our approach has been, let's try to prove our case and prove the trustworthiness of our autonomy through data and work with the FAA to make progress. And I think we've been doing a great job of that. And Dominion's a great example. So I do consider that validation and the kind of premises of some of these waivers is that the key thing is like you want to fly beyond visual line of sight. So you want to be able to fly behind a structure. Let's say someone's inspecting a bridge and they need to get to the backside, and it's really like not easy to access from where you're standing. Like you can't see it. You want to use the drone. You don't want to stop traffic and use a bucket truck or have someone rappel ways that are just obviously more dangerous and more expensive. and more environmentally impactful. So yeah, using the little electric drone makes a lot of sense. And if we can say, for example, that the drone will operate within, say, 50 feet of the structure, like that's called infrastructure shielding. And so that's one great avenue which we can kind of make a waiver for the FAA and make them more confident in saying, yes, like let's do this and then see where it goes. So if you can say you're flying within 50 feet of a bridge, well, you're probably a lot less likely to be infringing on any airspace in a dangerous way. And so we can say, all right, well, in this, this company can fly beyond visual line of sight in these kind of scenarios anywhere, or in this state, or things like that. So I think we're seeing tendrils of progress like that all over. And as we get to more and more kind of fully autonomous operation, we'll be pushing to kind of make our data case. And it's all about the data and the proving that you can trust the autonomy by example, and working with some of these really large, important utilities. They're heavily regulated and they need to be conservative out of necessity.
What part of that was the return to home feature? So when you're meeting with the FAA, or Dominion Energy's meeting with the FAA, and it's out of line of sight, and the FAA asks the questions, well, what happens if you lose connectivity? How do you get it back? Did your return to home feature help build that confidence and build that trust, knowing that there's a way for the drone to safely come back to home, if you want to use the term base, for example?
Yeah, that's a huge one. It's kind of everything in some scenarios. So there's all of these what ifs, you can call them kind of health monitoring or off nominal flows or whatever it is, but can the drone get back home? So what happens if it loses connection? What happens if it hits a low battery and it's on an autonomous mission? What happens if it starts raining, or it gets dark, or it gets foggy, or a camera drops out for some hardware reason, or any number of things? And so how we handle those is really key. And so one of the most common things here is, where does the drone go back? When does it go back? When does it abort autonomous operation? And the really interesting thing there is it wildly varies what you want to do depending on the scenario. So if you're a person that's just kind of standing with the sticks and flying the drone around and getting a sunset shot, then you want it to come back home. You want it to come back where it took off. And you probably would like just kind of be high up in the air, go straight over and straight down. Let's say you're skiing and you're filming yourself. You absolutely, let's say it loses track, loses connection. You don't want it to go back up the hill to where it came from, right? You want it to kind of meet you down at the bottom or come find you wherever you might be. And if you're inspecting a bridge with this kind of shielded operation, you absolutely don't want it to fly high up in the air, because often kind of you don't want to break the surface of the bridge. Like that's kind of sort of the plane where the cars can see the drone. Like that's considered outside of an exemption often, or whoever's inspecting, it's not allowed to fly there. That's a no-fly zone, especially if you fly over the traffic. And so there's cases where you want to use vision-based navigation. There's cases where you might be in a warehouse and you want to do kind of a complex backtracking, not go in a straight line, because straight line's never going to get you back. You'll get stuck. There's cases where you want to use GPS and go to pre-specified points. So it's actually a pretty complex topic, and getting it right is huge for robustness, especially when we talk about docked drones sitting at some remote site, right? No one's there, and the drone has to do an autonomous mission and make sure it gets back home to its, cozy home and lands in it. So that's absolutely a huge focus for all of the customer segments.
How does the drone know when it's time to go back home, or if you're skiing, to go to the bottom of the hill to go to the skier? What is it based on? Battery? Is it based on flight distance? What goes into that, where the drone says, "Okay, drone, we're going home"?
Yeah, so there's a system of health monitoring that kind of allows the drone to introspect itself and see what the problem is, and then there's a system of how to react to that. And so there's some settings that are configurable. So for example, if you are a user, you can always set a home point, and that home point will be where the drone goes if something is wrong, like it loses connection or it goes low on battery. In some cases, you're running an autonomous mission and nobody is you want to configure that beforehand, basically. And so in that case, you might say, keep doing the autonomous mission for 30 seconds or a minute, and then basically If you don't gain back connection, then you abort, then you go back with this way. So there's kind of high level settings where you can configure how you want it to operate. And then there's kind of, depending on the use case, like 3D scan has a pretty advanced and very different set of behaviors than if you're just tracking a person. So if you're tracking a person, you might be talking to the beacon device, which has a GPS, and you go to the last known location, or they've preset a home point. In 3D scan, you've got this notion of a 3D volume that you're scanning, and you might have a kind of a geofence where you don't want to fly outside of that. And there's a pretty careful determination of where the drone will return such that it's predictable and follows exactly what would be kind of within code of an inspector. So yeah, high level parameters, configuring the autonomy with kind of intelligent defaults based on what kind of use case we're in.
You mentioned 3D scan. Skydio developed it. You have a lot of public feedback from your industrial customers such as Dominion Energy. For our listeners that say, okay, 3D scan's interesting, how would you describe 3D scan, and what are the benefits that your customers on the industrial side are seeing with 3D scan?
Yeah, 3D scan is amazing. It's probably one of my favorite things I've ever worked on. So it's just an incredible tool. So the basic premise is going from a drone that can avoid obstacles to a drone that does something, a fully autonomous workflow that provides a ton of value. And so the basic use case of 3D scan is that you want to build a 3D model or capture inspection imagery of some 3D structure. It can be any 3D structure. And basically in the app with kind of AR helpers, you basically define a 3D volume. So it might be around a car crash or a house roof or a dam or part of a cell tower or anything like that. And then you hit go and the drone will kind of zip around it and build a real-time 3D map. And you can kind of see this mesh in AR on the phone. And then it's very exciting. And then once it's done that, you choose some high-level parameters like what resolution of imagery do I want, which is how close does the drone get? And the closer you get, the more photos it is, but the higher resolution. And then how much overlap do I want? Like how much between subsequent photos? And that determines kind of the quality of the 3D model you can get, especially for thin structures. So you specify those high-level parameters, and the drone makes like a capture plan that's kind of tailor-made, fitted around the structure that it just built a map of. And you basically just monitor it as it does this whole thing. You see the progress in AR. It kind of highlights where it's got coverage. And then you can take those photos and you can put it through a photogrammetry engine and build a 3D model. So the really, really cool thing is you can capture a 3D model of your house in 30 minutes with the drone. And you don't have to be a drone expert pilot, and you don't also have to be a photogrammetry expert. So normally if you're capturing photos for a 3D model, there's all kinds of domain knowledge of like, this is how you need to fly. These are the type of photos you get. This is how you make it work. And it really is super simple with 3D scan. You just follow kind of these step-by-step instructions in the sidebar to set some parameters and some basic things of specifying your volume, and the rest is done. So I think for all types of enterprise use cases where instead of training expert pilots and photogrammetry experts, you could really have your existing employees kind of be empowered to, whatever they're doing on site, they also can get a scan, create a digital twin. And it makes it way easier to scale out a drone program, either if you're a company that doesn't have one or has one, but it's, they're small teams and they have many other employees that don't know, aren't allowed to fly drones. And at the same time, it's also pretty cool for just individual users that have a small business or an idea to whether they want to create video game assets or preserve some structure for cultural heritage or whatever. It kind of just democratizes that ability to capture a 3D model there's ways to do it from the ground, but if you really need to access, the drone has the unique ability to go in close to stuff and also far away to capture big and small structures and to access the tops of buildings that, say, a car driving by or a tripod can't do. So that's kind of the overall picture of 3D scan, and it just really has amazing applications in so many different areas and industries.
The UI that the team at Skydio developed makes it really easy, but everything you just described in 3D scan and everything you described throughout this podcast so far, it raises the big question. Why was a decision made to develop a drone that just works. You don't have to go to flight school. You don't have to crash into trees and do all sorts of silly things like you had to back with the old DJI drones. It just works out of the box. For listeners, literally 5 minutes, read the manual, installed the app, updated the drone, and it was flying around, and it worked. Why did you make a drone that just works?
That seems like an easy one. I mean, you can see these tools, like it's a powerful technology. It has applications in every area of industry. It's also fun for consumers. So it's a really powerful tool and it's really underused. So there are more expensive, more dangerous alternatives. And yeah, the ability to make the tool easier to use, I think, is what allows it to be adopted and brought into the mainstream. So when the technology goes from, wow, this is a mind-blowing demo, to it's being used in every corner of the world by every S&P 500 company that has infrastructure all over. It can be flown by, somebody that doesn't really have a lot of experience with technology. There's a kind of a funny video of our founder, Matt's daughter, who was, I think, 2 at the time, is kind of flying and using the beacon to make the drone move around and run around. And it's just awesome to see. And so that's kind of the, you have a good autonomous robot when a 2-year-old can kind of use it well. And yeah, so I think just, bringing that technology into broad use is the goal. And to do that, being easier to use is, I think, the key. And so when it goes from that mind-blowing demo to like, this is a toaster. Toasters everywhere. People use toasters. They don't consider it state of the art anymore. And I think that's kind of what it takes to go from the demo to like, it's actually a widely used thing in the mainstream. And so I think making progress towards that, I think it's going to be quite a long time before it's toaster levels, but that's, I think, the kind of path to that we're on, and the thing that creates the most value, because it means this technology is being used over alternatives because it's better and safer and easier.
It's easier to use. I wasn't terrified when a bunch of 8-year-old girls were flying the drone that they were going to crash. They're giggling and having a great time. So they're not too little, 6 years older, but they had a great time, and I wasn't worried. If you look at use cases, I've used it on the golf course. I tag me on the golf course to perfect my swing. So that's another use case. There's all these really great use cases. And as I said before, it just works. If you take that, it just works. You combine that with a 3D scan, the incredible autonomy, and return to home features. Is that the competitive advantage of Skydio, as the entire complete package?
Yeah, I think so. So the autonomy is kind of, it's been the longest investment in our company, starting with our founders and their research. And so having the company built around the robot being intelligent and trustworthy leads to it being easier to use. But then also a huge amount of investment on the kind of product design and UI, UX side of things to make the user experience like paired with that. It's quite a tough problem of kind of human robot interaction to say, what's the right way to interact with an autonomous robot? You don't want it to be too clever, but you don't want it to be dumb. You want it to do intelligent things, but not too intelligent, not unpredictable. And how do you abstract away the right levels of like what it's doing internally with the right interface? So a huge amount of effort has gone into that. So yeah, I would totally agree that the autonomy combined with kind of the ease of use makes Skydio special. And then I think I would just add to that increasingly we're growing as a global hardware manufacturing organization that is operating increasingly at scale and able to really deliver on high quality, vertically integrated solutions, like the full stack up. It's really, really hard to build what we're building if you don't control every layer of the system. For example, Skydio actually started out being a company that was making software that we would kind of add on autonomy to existing drone platforms. But we just realized that was just too difficult to do because you hit all kinds of issues with the cameras and the vibrations and what's available in the stack. So to make a really, really good seamlessly integrated product, I mean, you can see this in cell phones and other kind of devices. If you want best performance, you kind of have to control everything. And so I think Skydio as a company has just been growing and scaling at doing that and getting better and better at that. And I think that's a big part of kind of our vision as well.
Does that go back to 2014 when the company was founded, where the software and the hardware came together?
Yeah. I mean, for the first, I would say, at least year or two of the company, it was, the really just working with off the shelf prototype, 3D printed kind of robotics, computer vision cameras, and there was no plan to actually manufacture our own hardware, and we didn't have any hardware people, and so that happened slowly, and it was just kind of a realization of the importance of tightly integrating the whole thing. Yeah, it does go back to that time, basically.
With autonomy being the longest investment, coming together in 2014, you've being employee number one or pretty close to there at the early days of the founding of the company. How has the autonomy improved, and how do you see the autonomy improving as we go into the future?
Yeah, so it's improved quite a lot. So some funny anecdotes. When I first started, the first thing I kind of was working on was object tracking of people. But at the time, we didn't have an NVIDIA computer. Deep learning wasn't available in embedded form at all. And the kind of some of the first videos of me were like, I had a giant printed out fiducial tag on me, and then just using kind of off the shelf software to try to detect myself. And then for the first few years, really up to raising our Series A, it was done on tracking blue shirts. We specifically were looking for blue Skydio shirts, and that's what we would kind of be able to detect and track. And it was kind of fun because we would give demos to people and always hand out our shirts, and then we get kind of good branded material with Skydio shirts. And so that was one of the bigger things, was making the tracking work with deep learning and ditching the restriction that you need to be wearing a blue shirt. And it's just kind of funny to think that that's what we did, and actually what kind of like we're betting the company on at the time. And so that's one example where things have just developed dramatically. I gave the example of the deep learning based obstacle avoidance, and just all across the stack. I mean, we put a tremendous amount of effort into capturing more and more difficult edge cases, like you're flying faster and faster. It's a more rare scenario. You're flying over a desert flat in Utah. You're flying in a high up area at sunset and it gets foggy, or you're flying up in a metal bridge girder and there's just there's nothing to see except some shiny metal. And how do you handle all those scenarios? And so we try to capture those edge cases and improve them. So that's kind of the core autonomy kind of stack, just pushing to get more and more robust. But then in addition to that, we've been building kind of this higher and higher level. So we have the 3D scan is a great example of something that just did not exist when we shipped Skydio 2, right? It had the great obstacle avoidance, but it wasn't able to do this higher level workflow. So the ability to build a map that's kind of persistent and to localize against it between multiple flights, that's just something we didn't have at all, that we only had a kind of a local obstacle map. And so those more global levels of mapping, map building, localization, and planning, especially to support our like dock, drone, autonomous missions, has been our biggest focus in the last couple of years. So basically building on top, like what can you build if you already have a drone that can avoid obstacles and fly autonomously? What kind of autonomous workflows can you build where it's not somebody on the sticks but they can't crash, but it's somebody specifying parameters like you're working through Google Maps or something, and then the entire flight is kind of controlled by the drone. So that's kind of been the biggest progress in our efforts.
Skydio's come a long way since the blue shirts. It was a great marketing campaign. Now you have great autonomy. Looking to the future, how do you see the Skydio autonomy technology scaling? Will you eventually put into larger drones, perhaps drones that can carry packages autonomously?
Yeah, I think that's totally likely. We're interested in different possibilities for our hardware in the future. And of course, I can't say anything about what's going to happen when, but I think drone delivery is a good example of something that I think it can have a ton of value in many use cases. And you can look at, for example, Zipline is a company that's doing some amazing things in the delivery space there. But also there's some ways in which it's been tried too soon by some other companies in some other areas. And I think from our perspective, it was kind of like drone delivery, especially in urban areas, is like, we really want to tackle that only when you've nailed down a lot of other use cases that require less. And just the payload of a camera sensor or various types of cameras is already general and kind of incredible enough to do a ton of stuff. So yeah, I think the technology totally applies. I think you'll get there, and I think there's possibilities for both what Skydio might build and what Skydio might sort of work with to enable we've got a lot to focus on at this point for our current vision.
The future is bright for your company. You're right about urban package delivery. It falls out of the sky. You're going to have the headlines in every newspaper around the world. It's going to hurt the technology. But if you look at a lower risk case, you go from a port to a boat. Because if it falls in the ocean, you can go have a boat rescue and you're not going to have the environmental impact. So perhaps that's somewhere that you go. But I like the approach that Skydio is taking. You're taking a measured approach. You're not trying to be everything to everybody. You're focused on developing a really great product and scaling that product. And I want to highlight that the company made a very important, in my opinion, a very important strategic decision early on that the Skydio drones are designed, assembled, and programmed and supported in the United States. Very smart move, especially in the political climate we have today. Why was that strategic decision made early on in the company?
As you noted, I think there's important kind of geopolitical implications there, especially as we have customers both in kind of state and local law enforcement and also across many different agencies and bodies within the government. And I think we increasingly see regulated industries like utilities, for example, that do care about the kind of security and geopolitical aspects there. So yeah, I think that's a big part of being kind of an American company and who we serve. And the other side of it is kind of what I mentioned about controlling things. So I think the closer that we bring our manufacturing and our full stack and supply chain to home, the more kind of control we have to be kind of assured in its security and longevity and be able to move quickly and change things. So I think it is a tremendous amount of work and a challenge to kind of have that kind of pushing towards more local sourcing and manufacturing, but that's why it's a goal for Skydio.
Well, it might be a challenge today. As I said, I think it's a strategic decision. It's a decision that will benefit the company long term. And in my humble opinion, it was the right decision. I've learned a ton during this conversation, and I want to ask you this as we look to wrap up. What is the future of autonomous drones?
Yeah, it's a great question. So we have this kind of idea that we call the arc of autonomy. There's a graphic that goes along with it. This being a podcast, I'll kind of try to highlight how it moves kind of from the left to the right, going from what I described with one pilot on the sticks to a fully autonomous kind of skill or workflow like 3D scan, where someone's just, pushing some high-level instructions. And then you keep moving to the right, and the big thing that gets introduced is the dock. And so that dock product where you have a drone, maybe at an energy substation or maybe at a shipyard, and it's a cloud-connected home base. It could be sitting anywhere. It could be in any corner of the world, and you can remotely operate it, or you can program autonomous missions to run. So for example, scan this building every day, or run this kind of circuit around the perimeter, take photos, look for things, sync them to the cloud. And those kind of scheduled autonomous missions combined with docked drones take you to the level of like one person can be monitoring many drones. And if you keep going on, you can have many docks at a site. They can run missions in parallel. And you keep going, you kind of have this world where maybe even the drone is more of a service, right? So say you've got a docked drone installed at your shipyard or attached to the cell tower or something, and that drone can do a whole bunch of things for a bunch of use cases, and it can just be programmed through software and it's cloud connected. And so I think that kind of vision of a docked drone that is really fully autonomous and is built around kind of 3D maps and mission planning is really the vision of the company, and what we think is kind of like the really largely untapped enterprise drone space where we're still super nascent in big companies having small drone programs and kind of manual flight to the level where you can really have a large fleet of these docked drones that run all sorts of different missions. And it's just like a huge enabler. So that's how I see it, what I'm excited for.
It's scalable and it's cost effective. And the fact that it just flies and as I said earlier, it just works means it could be implemented without having to have all the resources and cost to train pilots, and individuals, as said, as little as 5 minutes can become a dock operator. So I love the explanation of the arc of autonomy. And as we look to wrap up this insightful conversation, what would you like the listeners to take away with them? We've covered a lot today.
Yeah, I would say if you're interested in Skydio, watch our videos and try to get your hands on it to try it. So it's a funny experience where you're skeptical at first, and then you run around, have it track you, or do something with it, and it's pretty awesome to just see firsthand. And then I would say people learn to trust it too much. So after a few minutes, you think it can do anything, and of course it has limits. Of course, you need to be careful as well. But yeah, if there's one thing I would say, if you think there's an interesting use case, check it out and try to get your hands on one and try it, because there's a lot of possibilities, and we don't know, we don't know all about it. And, I would say if you're interested in kind of robotics, that's one of the great things about our drone, is that you can really, it's a great canvas for doing robotics research and experimenting, because it's small. You can fly it in your backyard. We can iterate on it quickly. So it's an awesome platform for us as well to kind of make progress. So I appreciate the listeners tuning in, and I hope they check us out in some form.
If you have the opportunity, order the Skydio drone. They're currently on sale. If you follow Skydio HQ on Twitter, you can order it there. Go to Skydio's website. Try it, as Hayk said. Learn to trust the drone. When you learn to trust the drone, you'll fall in love with the drone, because the future is bright, the future is autonomous, and the future is Skydio. Hayk, thank you so much for coming on the Road to Autonomy today.
Thank you so much. I appreciate it. Have a great day.
Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter @Road to Autonomy, or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed on this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.